Hi, hello. Welcome to this new webinar regarding the upcoming release of the new service pack for CivilFEM 2018 of powered by Marc. Thank you very much for attending. And as I told you, if you already have any version of CivilFEM 2018, you will be available to download the next service pack. Well, one of the many and new features is the capability to define a new nonlinear concrete material model by modifying some values of the cracking data. Here you have them, and we'll show you just a simple example. We will have a special or specific webinar for a fiber reinforced concrete, but today we just show you this new capability. If we go to the cracking data, before the softening modules was constant. If we have concrete, just here you have the stress and strain chart. Here, before we can just, if we set a critical stress for concrete, we will take this branch until the critical stress, and then have a constant softening modulus, so we can have this a kind of abrupt value of the stress going just to zero, or we can just modify it a little bit if we want to have a slope. But now we have this new capability, so we can add different branches or use a variable softening modulus table, so we can get this this utility, and it's very useful for defining the behavior of fiber reinforced concrete. So here we have these parts. First, the first crack of the concrete, and then we can add hardening or softening. Okay, in this case, we'll show you just a simple example. Once the tensile stress are acting on the concrete, we can set different branches to our concrete behavior. Okay, if we have, depending on the low or high content on fibers, we can simulate this behavior. Okay, instead of having just a constant softening modulus, now we can simulate hardening and softening on concrete. Okay, how we add this new capability? If we have, we start from the beginning. Okay, this is just as I told you, we will show you new a specific webinar on concrete, fiber reinforced concrete. The main change is here in cracking data. We set a critical tension stress, and here, if we check the variable softening modulus, we have here our strain data and the value of our stress, and we can define different branches. Okay, here we have this behavior. It's always a softening, but we can define hardening as well. We have our critical stress, then for this strain value, we set 1.5 megapascals, and then 0.5, and then to 0 for this strain value. Okay. For our load groups, or we just set 3 different imposed displacements, and we solve it, okay, with this material. Later we'll show you the other new enhancement, which is the if you know before, if we solve a model, we have always to choose the location of our load cases. Now with the new results manager, they will be always here. Okay, you don't need to select them because they are all in this new results manager, so it's easier to see results. So if we want to plot any value, we just go here, and instead going one by one, we have them here. But well, one of the I will plot the strain and stress values of these new crack softening variable modulus, and we can plot here. I will plot with the history plot stress and strain. Here we have it. Now we have here the behavior of, we can see the stress and strain diagram chart. Here we have the critical stress, the softening until loading, and then unloading, loading again until 0. So this is one of the new capabilities of the new service pack for defining a variable softening modulus, and one of its application is the fiber concrete, fiber reinforced concrete with steel or with any microsynthetic materials. Depending on the data of your material, you can define your variable softening modulus table. Okay, if you have your stresses and strain values. One of other important addition to this new service pack is a new material model for soils, nonlinear material model, the hyperbolic model in CivilFEM, which is one of it's created or coined by Duncan and Chang, and well, that's why it's known as Duncan-Chang models. And we have 2 versions using a variable Poisson ratio or a constant. Okay, this is one of the capabilities of the Duncan-Chang. If we want to unload or reload a soil material, and we have this data. If we open our simple example, if we go here and add a new material, one of the new, besides Drucker-Paragh clay, Morculum, and nonlinear elastic soil model, we have the new one, which is the hyperbolic. Okay, and we have here all the data needed for this model. Very useful for to simulate loading and unloading tests. And then of course we can always make use of the history plot to check any results. Okay. We are as well. We can always develop any type of new material model. We are developing a Huygens and Brown model, but we are for the next 2018 version. We are open to new material models, so please feel free to suggest any new capability, not only material models, but any other capability that you might find interesting or useful for your analysis. Please contact us for any new development. Besides the fiber reinforced concrete and the Duncan-Chang hyperbolic model, we add now, because most of our users demanded it, we can do it before to use shear strength reduction method. By just this method will reduce the strength characteristics of the soil by a factor. For more Coulomb, we will reduce in an iterative way our cohesion and our friction angle. And before this service pack, it has to be done in a manual way. I mean that if you have seen our previous webinars regarding slope stability, you will remember that this cohesion and friction angle were divided by a safety factor, and we solve the analysis until the collapse of our slope, until the failure. This had to be manually. We solve with one safety factor, and then if it's okay, the displacements and plastic strains are not reached, then we increase the safety factor until the non-convergence. Okay. As we say, the critical factor will obtain the critical factor at which failure occurs. Well, here we have an example. This is just a 2D slope stability analysis, and here a new capability. Well, we just set initial values for the cohesion and for the friction angle. Before we had to, we can set a parameter dividing these values and then modify it for each load case, for each solution process, until the collapse of the structure. Now we can do it just by selecting a more Coulomb material, setting the value of these properties, and then in the load case there's a new checkbox. If it's checked, we will have this new strength shear strength reduction method controls, and we set these values. The minimum factor, safety factor, to be which is 1, unmodified, and then our maximum factor, safety factor, which will be dividing cohesion and friction angle, and the different steps, the increments that we want from one value to the next one. These values will override all the solution controls that were defined here in the global configuration of the solution process. This one will be the ones to be used. If we solve the analysis, we will, again, I will show, you will see that automatically once we have all of our results, we'll have them here. And here we have, if we click the information button, here we have, this is the important column. We have solved all these load cases, and our final safety factor is this one. This is of safety factor, and depending on the fraction that we have, step fraction that we have defined, we have these values. And for example, if we want to plot displacement, we can check them here, and using this button, or we can animate as well. We'll see here the final result, and we can check as well the plastic equivalent plastic strain for our last solved load case. We can always animate and we have here animation of any result. This case was the displacement. This was with the undeformed model, but if we want to deform it, here we have it. Okay. And of course, we can always check our history result. On our results, and plot or decide want to plot 91 element, and here is the evolution of my plastic strain. We can as well plot any result. Okay, the displacement of any node, for example. X displacement, so we can see. Now this process of the shear strength reduction method can be done automatically with this new service pack. Just as I told you, setting our cohesion and on friction angle, which can be variable as well if we want. And then the software will get the safety factor as a result. In this case, our safety factor is almost 1.17. Okay. Well, these are our main Shear Pack new features. Other new features are the automatic hydrostatic pressure load definition. Before, if we have here if we want to define a load, now we have this new for the same for if it's a surface load. Besides a linear load, now we have a linear hydrostatic pressure. We just set the height of where do we want to set our pressure, the height of it, and it will be automatically defined. Okay. If you want to set it here. We will have a new, well, I didn't set here. You will have our pressure up here applied. Okay. Other new enhancement will be the new user results. What are the new user results? Besides having all these results, okay, maybe we need other results defined by the user. The way to do it, maybe defining an equation using the existing results, or defining a new result from existing or new ones. There's a way to define new results. It's available currently using Python scripts. Okay. You have more help in the Python manual of CivilFEM. For example, here you have in the user results, we can define a new result. We will show you now how to define a new Tresca result, or we can increase our result by a factor. We can do it as well. Here, for example, if we, here we have our Python script editor. We just select our results file, and we use one of the values that it's available, which is some stresses in some directions, and we set this new Tresca value. Well, maybe for this example, it's not a very useful, but we set here by using a formula for all our nodes this new value. If it's launched, then here we will have you see here the new value. It is available now. Okay. Other new enhancements are the new results manager window, which I showed you before. Now the results are available here. You don't need to load them one by one. And other new results are the principal strains. Minimum, maximum principal strains are new as well for this new service pack. Okay. This is all of the new main enhancement, besides correcting some minor issues or bugs. But just want to tell you that for this end of the year, there are special offers. If you are interested in purchasing CivilFEM, please contact us, because we have a very interesting discounts, and of course you have always our technical support team to solve any issue or doubts of how to use CivilFEM. So please well, stay tuned for these special discounts for the end of this 2018. Other ways of learning CivilFEM are two platforms. If you just want to know to use the software, you have the International Online CEA Education Center. Okay, we have different courses there, and it's very well, flexible for you. You can enroll in any time. Please, if you check this website, you will get more information. And if you want to add to your practical knowledge of the software as well, the fundamentals and more theoretical knowledge, you have the International Masters in Theoretical and Practical Application of the Finite Element Method and CEA simulation using our UNED platform. We will start our 25th course with almost 4,000 already registered engineers. The registration is open, so feel free to contact us or enroll to our next course. And well, thank you very much. Stay tuned to our social media, and if you have any questions, we have these contact emails. And of course, if you want to download a free version of CivilFEM, please visit our CivilFEM website. Okay. And thank you very much. Please, if you have time, you can complete our shared survey that will appear once you finish your once we finish the session. Thank you very much. If you have any question, you can ask them in this application, or you can send us an email to support@civilfem.com. So, thank you. See you in next webinar. Bye.